This is Pre-Calculus On-Ramps Function Patterns. And the top of this worksheet says, use your knowledge of function patterns to answer these questions. At this point in the year, you have the skills to determine the regression function for linear and exponential without using a calculator. However, if the function modeled is quadratic, power, or logarithmic, a calculator is needed. Now, you can determine without the calculator if it is linear, if it is exponential, and if it is quadratic. But then to actually find it for quadratic, better off using a calculator. You can do them by hand for linear and exponential. If it is linear, then when the x differences are the same, the y differences will be the same. If it is exponential, when the x differences are the same, then there will be some ratio between every y distance, like everyone is double or everyone is half. If it is quadratic, when the x differences are the same, then take the difference between the y's and the differences between those differences. It's called the second difference will be the same. Then again, when you are finding linear and exponential, pretty easy to then by hand figure out what the function is. With quadratic, power, or logarithmic, you need to do a calculator with regression. I will do it for the problem I'm about to do using Desmos. Most students in school will use a TI-84. And for power and logarithmic, just try the regression and see which one comes up with an R value of 1. So I'm going to do this question number 4. Let me see if I can get the whole thing on the screen. It says below is this table relating speed of a vehicle and its stopping distance. Speed in miles per hour and stopping distance in feet. Determine the stopping distance at 70 miles per hour. Well, let me check this out. I don't know what kind of a function this is, but let me find the first differences. The difference between 14.6 and 35.9 is 25.3. The distance between 39 and 75 is not 25.3. This isn't linear. 35 would be 74.9. Yeah, this is 35.3. And then the difference between 75.2 and 120.5 is 70, 85, 95, 105, 115, 5. Yeah, that's 45.3. I guess this would be a calculator section, so you can just do these on a calculator. The difference between 120.5 and 175 is 55.3. So there's the first difference. So this isn't a linear function. There's not a common ratio between these, but if I look at the second difference, it's 10, 10, 10. Determining the stopping distance at 70. Well, so between 50 to 60, it's going to be plus 65.3, so it's 175.8 plus 65.3. And then from 60 to 70, it's going to be plus 75.3 because the second difference is always 10. So I'll just add that one too. So this is 8, 9, 10, 11, 12, 13, 14. I guess you can use a calculator to do this. 15, 16, 13, 14, 21, 316.4. 316.4 feet. Then use the function properties that you learned previously to make a conjecture as to the type of function. What's quadratic? I know that because the second difference is the same. This could be something like y equals ax squared plus bx plus c. And then why can't I use the pattern to find 25? Because it's not a difference of 10. It has to be a multiple of 10. I say not a multiple of 10. The MPH is not a multiple of 10. I can only use a pattern to find 10, 20, 30, 40, 50, 60, 70, 80, 90, 0, etc. Find a particular equation and verify that all the d values in the table satisfy. Well, I'm going to use a regression, and I've already got it here, but I'm going to start it from scratch. I'm going to do it on Desmos. You can do it on the TI-84. My x values are 10, 20, 30, 40, 50. I'm only going to put the ones that they have given. I am not going to use the one I found. 14.6, 39.9, 75.2, 120.5, and then 175.8. And then on Desmos, I'm going to press, on TI-84, you press Stat, calculate, and then go down to, I know it's a quadratic, and it will give you the equation. I'm going to go here, quadratic, regression, and see this r squared value is 1, so that's good. 0.0, in the real world, when you're using real data, you're not going to get ones most of the time. You might get 0.4 or something like that. 0.05x squared, find the particular equation. I'll put f of x equals 0.05 x squared plus, I think it was, 1.03x minus, I think that was a minus, 0.7. So there's the equation. Then I have to find when x is 25. So on Desmos, I can make the equation. I'll change y to f of x, because then I can just do this, f of 25, and that equals, you can just plug in into this equation, 0.05x squared plus 1.03x minus 0.7, just plug in 25, and you will get 56.3 feet. Now this says, at what speed will the stopping distance be 100 feet? Give both the exact without calculating an approximate. So I'm going to take the equation, 0.05x squared plus 1.03x minus 0.7, and that equals 100 feet. And I will subtract 100 from both sides. I get 0.05x squared plus 1.03x minus 100.7 equals 0. And I'm going to, this is not going to factor. I have to use without the quadratic equation. So remember, this is a, b, c, and I need negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I will do 1.03, but it's got to be negative, plus or minus the square root of 1.03 squared minus 4 times 0.05 times negative 100.7, did not fit, but I squoze it in there, and then divided by 0.128. That's the exact answer. Now you can calculate this part and get what's in that parenthesis, and then negative 1.03 plus that divided by 0.1, square root of that, negative 1.03 minus the square root of that over 0.1, but that's all we would have to do. Well, I'll do this on Desmos. 1.03 squared minus 4 times 0.05 times minus 0.7, is it 0.7? Oh, minus 100.7. That comes up to 21.2009. So this is negative 1.03 plus or minus the square root of 21.2009, all divided by 0.1. That's the exact answer. And now I probably want to see if one or the other of them can't really be an answer. So I'm just going to put y equals 100 on my graph. You can just calculate these, negative 1.03. Well, I guess I'll do it. I'll do it the way you have to. Negative 1.03 minus, negative 1.03 minus square root of 21.2009, all divided by 0.1. I get negative 56. Well, that doesn't mean 56 miles an hour backwards. It means negative. The car is going negative. Is it a truck, a car? I can't remember. A vehicle. The vehicle is going negative 51, which doesn't mean reverse. It's not a realistic value. So then I'll do the plus, and I get 35.744. So that's the approximate answer. Approximately 35.744 feet approximately. And I could have done it just like this. I graphed it and then y equals 100 on Desmos, and I get those two answers, 35.744 and then the negative 56.344. But again, that doesn't mean in reverse, because it doesn't, a car going in reverse doesn't stop faster than the car going forward. So 35.744 is the answer for the last part.